All right, class.
Hello.
Hello. All right, so now for all you people, we are going back to, hey, have you ever seen you with your hair down like that? Seriously. Anyway, all right. So, okay, so this is what we're doing. So we're doing some math.
Yes.
Okay, yes. Okay, I handed out. Oh. Pacho's petting zoo. Okay, they're apologizing for the noise. That's kind of funny. Anyway, all right. Oh, where was that? Okay. Okay, Rolle's theorem, work with mean value theorem, and identifying where a function is increasing and decreasing. So, now this is the good stuff right here. Let a function be defined as on a closed interval. Now, for it to be defined in a closed interval, what has to happen? Closed dot. What else? Huh? It's got to be continuous. Okay? Brackets. Brackets. Closed interval. That's super important. Okay? Continuous. There means brackets on those endpoints, and there is no holes, jumps, or discontinuity. F is differentiable on the interval from A to B. Now, if you notice, that has parentheses. So what does it mean now? Yes. Can I take a derivative on the endpoint? No. That's the point. I'm not taking a derivative of the endpoint. Okay? I don't, yeah, because at the end, if you think about it, at the end, they can't really, for those people at YouTube, right now, I'm like holding out my finger, and like the slope right at there, at the end of it, like you're balancing, it doesn't work. Okay? There's no real slope on the end of it. So, I got a mess here. Anyway, okay. And f of A is equal to f of B. Now, what does that mean? It says f of, not f prime. Excellent. The y values are the same. The y values are the same of the endpoints. So if I were to sketch a little graph, and so it would be like this. Something like that. So the endpoints are going to be the same, not in between there, right? Then there's at least one number, C, in the open interval of A to B, where f prime C is going to be equal to 0. Now, what does that mean? F prime is equal to 0. Okay, it's going to be a horizontal, right? So that's going to be, it's a change. That's going to be a min or max, which is right here. That's going to be my C value. So on the endpoints right here, for the endpoints to work out, okay, it's got to be some type of curve that there's got to be at least one point inside there where the derivative has a slope of 0. Okay, so the derivative gives me that there's going to be either a min or max somewhere in there. So if you think about it, what goes up must come down, right? So, and that only works for this way. But, we can't really say what goes down must come up, right? That doesn't work, but yes, it would work out the same thing if I had a graph going the other direction. So if it was like this also, oh, come on now. Like this, you'd be the same thing here. And that would be C also. So either way, so if it has the same endpoints, somewhere in between there, it's going to have a derivative equal to 0. Find the x-intercepts of this and show that f prime of C is equal to 0 for some C belonging to the interval formed by two x-intercepts. Find C. Find the x-intercepts. Okay. What does the word intercept mean?
Where it touches the x-axis. Right?
Yeah, where it touches the x-axis. So those are going to be my points, right? So if the two places where it touches the x-axis is my ends, right? So that's going to be my f of A and my f of B, right? Those are going to be my two places where it's going to work out. Now, this should be a simple factorization. It should, being the key word, should. So being that's going to factor, it's going to give me what? X minus 2 and 3, right? Okay, so x minus 2, x minus 3. So there's my factorization, right? So x minus 2, x minus 3. So where is x equal to 0? Using zero product rule, set that equal to 0. So x equals 2 and x equals 3. So my A value is 2, my B value is 3 on my closed interval, so those are included. There we go. So because of that, the line has to curve somewhere. And it has to curve somewhere between these two to work out. Is there any discontinuity in this function? Is there any place where it's going to be undefined, or that I cannot take it because it's going to give me like an imaginary number? No. Okay? So this is going to be fine. There's going to be no discontinuity. There is no restrictions on my domain. That's going to work. So now let's go ahead and take the derivative. So my derivative, so f prime of x is equal to 2x minus 5. So 0 equals 2x minus 5. Add 5, so x is equal to 5 over 2, which gives me a decimal of 2.5, right? Yeah, it's 2.5. 2.5 equals x. Is that in my interval? Yes, it is. So that means it tells me that there is going to be a c value. This is my c value. It's inside that interval where there is going to be a min or a max. We're eventually going to talk about what the c value is going to be by figuring out something else also, but we'll get to that later. That's gonna be on concavity. So using Rolle's theorem, find out where the ends are. The ends have to be the same, right? And if it is continuous, then I should have a c value somewhere in between there that is going to have a derivative, or a min or a max, a derivative equal to 0. Okay? Does that make sense, or did I just say a whole bunch of words and like too many? Are we good? Odin, you all right?
Yes.
Okay, good. I don't know if you realize, but I give like slight variations of your name all the time.
Yeah.
Okay, all right, good. Okay. All right, so let f be a function defined on a closed interval, a to b, if f is continuous. On a to b, f is differentiable on a to b, then there's at least one number c in the open interval of a to b, which the derivative is equal to the secant line. So here's the hint. Slope of the endpoints. Slope of the endpoints. So, like, add this to your notes. Okay, what this means right here is slope between endpoints.
Oh, that's the
No. That's what all this right here is.
oh.
So, what it actually means, so we've been setting my derivative equal to 0 all the time now, right? This time we're not setting it equal to 0. We're going to set it equal to the average value from between my endpoints. So that what that means is the slope of my two endpoints somewhere in here must also be equal here. So whatever slope, let's say this slope right here is, let's say 1/2. It's a positive 1/2. So somewhere on my curve, there must also be a point where it's also equal to that same thing. in this case, come on. There we go. In my case, it's right here. Does that make sense? So now, in this case right here, mean value theorem. What does mean mean? Not just regular teachers, okay? Not hating on you, Dr. Bragg, but, okay? Not just mean. Mean means average, right? Okay, so we're finding the average between the endpoints and set the derivative equal to that average. Find the slope in between the endpoints, set the derivative equal to that slope. That's like the biggest, simplest, boiled down, nuts and bolts. That's exactly how you do it. And I know you guys all wrote it down because some people trying not to fall asleep because I am that boring today. Okay, so I know you guys wrote it all down, right?
Yeah.
Okay, did you write it down? What did I say? Yes, you.
Me?
Yes, you, Fonzie.
Between them.
Okay, so what are you doing?
So you're literally finding the mean right in the middle and then the slope of the curve.
No, start at the beginning.
Like going in between
Find the slope.
two endpoints.
Find the slope being between the endpoints, right? And then set your derivative equal to that slope. Escriba, por favor. Please write it down. Like seriously, that's like the most basic. You know, I translated Mathanese to Fonzie Berries right there. So hopefully write that down. So the slope of the endpoints, set it equal to the derivative. Mean value theorem. Verify that the function blah 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 in between that interval satisfy the conditions of the mean value theorem. Okay, so if it satisfies the conditions, first thing I'm going to find is
The endpoints.
the Fonzie, what I had you write down.
Find the endpoint.
Not endpoints,
The mean
Slope.
the slope
Between.
between the endpoints.
Well, we don't know
The
yet.
slope between the endpoints. The slope between the endpoints.
Well, we don't have the endpoints.
Yes, you do.
Oh, it's when it hits the x-axis, right?
Oh, wait, that's it? Oh, that's. Oh.
What does that mean? That's my interval, right? That's my interval. That's the reason why I told you to write it down. Find the slope between the endpoints.
Okay.
So f of 1 minus f of negative 1 over, oh, come on, 1 minus negative 1. Do the math right now. What'd you guys get?
I got negative 2. Somehow.
I got 5.
All right, I'm actually getting worried here now. Insert page.
After.
Okay, so f of 1 minus f of negative 1 over 1 minus negative 1. Okay, let's start with the bottom. So the bottom's going to give me positive 2.
Yes.
Yes?
Yes.
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 Yes?
Yes.
Yes.
Okay, so my function was x cubed minus-
3x plus 5.
So f of 1. 1 cubed is 1
Oh, it's negative.
minus 3 plus 5. That's going to give me together 3. Okay? There's 3. All right, and the other one is going to be negative 1. So it's negative 1 plus 3 plus 5. 7?
Yeah.
Okay, so I guess I was off on mine. So that's going to be 7. So it's minus 7. So that's going to give me, was it negative 4 over 2, which is?
Negative 2.
There we go. Good.
Yes.
So yeah, see? You didn't see that. Okay, so
It's recorded.
negative 2. There's irony. I'm being sarcastic. Yes, I did. Okay. Man. Sarcasm. I just invented it the other day. Okay. So it's a new thing. Okay. Anyway, we found the slope, right?
Yes.
Okay, so the slope has to be negative 2. Now, satisfies the condition. Now, find the numbers of C guaranteed by the mean value theorem. Find the numbers of C. So I'm going to take the derivative. So that's going to be, so f prime of x is 3x squared minus 3. Yes? And set that equal to
Negative 2.
2, negative 2.
negative 2. So this is changing to be negative 2 equals 3x squared minus 3. Add 3, that's going to give me 1, right? 1 equals 3x squared. 1/3 equals x squared. X equals plus or minus square root of 1 over 3. So that's going to give me plus or minus rad 3 over 3 equals x. Yes, I did rationalize. You got, yeah. Now, does it satisfy those conditions? It's a radical, so I kind of have to use a calculator on this, right? Because I don't know my rads that well. It's like 1.7 over 3, which is like,
0.57735.
okay, so 0. Point what?
57735.
Okay, oh, where am I at? Okay, so it's 0. Point what?
57735.
Okay, so now, is that inside my interval?
Yes.
Yes. Is there also another one? There's a negative version, isn't it? All right, so there's a positive and negative in there. So there's 2 places in which my C value is going to be equal to that slope. Yes? Okay. So I should be getting close. All right, interpret the numbers geometrically. So geometrically means, let's take a look at the calculator on this. So y'all pulling up y'all calculator, right? Y'all have y'all calculator in your hand. Yeah, it's way over there. Get off your butt. Man, some people. Okay, so let's go ahead and graph this, please, to show it geometrically so we could actually see what it's supposed to look like. And what is my interval of this graph supposed to be?
Negative 1.
-1 to 1. So I'm going to pull up my graph. So it is my function, which is going to be x cubed minus 3x plus 5. Enter. Okay, so let's go ahead and take a look. I'm gonna close it off. So I only want the values from -1 to 1. Menu, Windows settings from -1 to 1. Okay, now do you think my Y value is okay? Let's look and see. All right, from -1 to 1. Okay, so let's take a look. So I know it's going to curve up here, down here, right? So from there to there, it says that there's two places where it's going to be right about here and here, where it's going to be equal to the slope of -2. Is it all going down here? It's all going down, isn't it?
Yeah.
Okay, so that's good. So now let's actually try this out. So let's go menu, analyze graph, and what do I want to analyze?
The derivative.
Derivative, and I want the derivative where?
-2.
So watch this, control, divide. It's going to bring me, crap. Hold on, let me see if I could actually pull this up. Control, oh, there it is. Square root of 3 over 3, right? So yeah, because I'm off the screen, so it doesn't help me out. Square root of 3 over 3, right? There we go. Hey, look. It gives me my point right there, and my slope is -2.
What about the other one?
Let's do the other one then. Here. You know what? I'm going to use my... Because it's kind of hard to see. So, by using this, it's going to go control, divide. It's going to open up a thing, and I go control here. Square root. Got to set it up again. Analyze, and 5. So, control, divide, control here. Square root of 3. Doesn't like me today. I know. Alright. Okay, I guess it doesn't like my fraction form. And I want the negative, right? There we go. There we go. Alright, I was able to plug it in. So look, I have two places on here where my slope is equal to -2. So it has satisfied my mean value theorem, and I've also showed it graphically on my calculator that my slope is -2 at those 2 points. You guys feel pretty good about this? You guys like this calculator? Because this calculator is like super special.
Yes, it's amazing.
So just using the calculator is actually, it helps out a lot. It does. And the act of using it helps you out because I keep telling you guys all the time to keep putting stuff in the calculator. Yeah, it's good. All right, questions? Because I'm going to leave off on this example for today. No? We good? All right, I already sent out the homework for this. So you guys can start on this or try and finish up with the 4